Let's say you have a 3D vector problem. Let's read as one on screen. Let P be a point with positive coordinates. Suppose P uh, is is 40 meters away from y-axis, and y-coordinates of P is 3. So we'll try to first try to draw a visual presentation of what we're talking about. So first foremost, we're going to have our Cartesian plane. Okay, I think let's look more of something like this. Then this is your y, this is your x, and this is your z. So the next thing, let's try to put data that we have. So P is like 40 root of 40 meters away from y-axis. So if this is a y-axis, this thing is like 40. Point is here, root 40 meters away from y-axis. And y coordinate is 3. Here we have 3. Now we see a triangle making up. So because this is 90 perpendicular, this is a 3D vector. So the first question is find the angle that OP. O is the center and this is the P, the subject's point. So they want the angle that it makes with the y-axis, this angle. Then obviously we're going to use your basic trig math. You'll just say this is the opposite and 3 is adjacent more than tan. Let me call that angle. Let me call it beta. Okay, and now I need to find this angle beta. It's equals to opposite of which is root 40 all over the adjacent for the angle is 3 as given. So you can work your calculator here, and if you work your calculator very well, you're going to get an answer of 64.623 degrees, and that is going to be our angle beta, the angle here. Now the next question they is saying assume that P is also 17 away from Z. So if this is P here, this is Z axis, it is like 17 root 17 away, root 17 away. Find those coordinates. Now if you could notice, like you have another triangle form here of which is only OZP. OZP is on different axes as PO POY. So as a result, these angles are not complementing each other exactly. So they are on different planes. So it can't be this plus this equals to 90. So we have this triangle, and the only thing we have from this triangle is this perpendicular side to the axis, of which the distance away from the z plus z axis. So we can find this side they share, of which is the hypotenuse of the other triangle, which is also the hypotenuse of this triangle. We could just use Pythagoras to find that because we have this and this, or you could even use another trig ratio to use this to find this, but Pythagoras is way safe, where we say OP, distance OP, which is a vector, is equals to the square of the other side, of which is 3 squared plus uh, root 40, and it is squared, and that all should be under a root. So then here you make it 9, here you just double cancel, make it 40, and you put all under root, and you'll have your 49 under root, giving you 7 plus 7, because this is distance, it's a scalar. No, it's absolute. Then 0 OP, whatever I'm saying, and this is a distance. So we now know that OP OP is equals to 7 meters. The angle, they wanted the coordinate, so that means they want this side. So if I have this side and this side, I can get this side with Pythagoras, or I could just use also the trig ratios. If I have the angle, which I don't, let me not find the angle, find this side. Okay, so it's going to be Pythagoras again. OP is equals to root of the other side. It was 17, if I remember very well. 17 squared plus the square of OZ. Let me call it OZ. So from here we know this one to be 7, and here I missed this. 17 was under a root, obviously, so that 2 is going to take it out. We're going to have 17 plus OZ squared, that root, and that root I'm going to cancel it by squaring, and then it is not it just went away, and now I'm left with 49. 49. Here I have 17 plus squared OZ, then 17 go the other side. 49 minus 17 is equal to a squared OZ. So work this on a calculator and get 35, obviously, as equals to OZ. OZ is still squared. Then I have root 35. So that means here we have z coordinates to be root of 35. On the next question, on the previous question, I think I made a mistake here. I put 35 was supposed to be 32, but yeah, you see it now. So now they're saying you have enough information to calculate the direction of cosine alpha, of which is this angle that a vector make with the x-axis. So first, we know this one, but we don't know this one. I attempted to do it up and I didn't. Let me just fix it now. Now I have this and I have this, either way. So I could use tan because I have this side and this one. I can either use this one. Let me use because I just calculated OZ, so it's going to be tan alpha. That alpha? No, not alpha. That and tan its opposites is equals to 17 root 17 all over root 32. And then you do your math here, you get your answer. If you did your math very well, this is what you're going to get as an angle here. So we have this third angle remaining, of which is angle alpha, they said. So let's try to get angle alpha then. So there is this thing that we proved the other day, that cosine of beta squared plus cosine of the next angle, this one with z-axis squared, plus cosine of what is this one, alpha that we're looking for, squared, true, and will always equals to 1, and then we can try to substitute all this and get what we don't know, or exactly what we need. Cosine, it's adjacent, right? And what is the adjacent of b? It's 3. Then it's going to be 3 all over the hypotenuse. We calculated to be 7 just beginning of the video. It was 7, that is all squared, plus of this one, this is this angle here. Cosine is adjacent OZ. We did calculate OZ. Let me go and check it. Oh, and they said OZ was root 32 all over 7 for the hypotenuse, all squared, plus cosine of the angle that we want is equals to 1. So we'll just do some math here, and after distributing the square inside, that's what we get. Here we're just going to take one base. Obviously we have 49 all over 9 plus 32 plus cosine of this angle squared is equals to 1. Then obviously take it to the other side and solve for this angle that we're looking for. And if you did your computation very well, I don't want to waste time trying to do all this thing. It should be 66.17 degrees, and that is your angle that we're looking for. So we solve the problem.